So, in effect of height on barometric pressure, as we go up, the length of the air column exerting pressure decreases. See, look here. As we go up, see, this is sea level, and here this is suppose the top of the atmosphere. This is the height of the air column. So, height of air column is maximum here, and therefore pressure at sea level is maximum. As we go up, the height of air column goes on decreasing. With that, atmospheric pressure, because air applies atmospheric pressure, so atmospheric pressure also goes on decreasing, right? So this is what is mentioned here. As we go up, the length of the air column exerting pressure decreases, hence the atmospheric pressure also decreases. Similarly, if we go inside a mine, right, then the height of air column goes on increasing, because if you are going in a mine, more air will be there above you now. So height of air column goes on increasing, so does the pressure also goes on increasing. Okay, moreover, while going upward, density of air decreases. Density of air also decreases as we go, which also accounts for decrease in pressure, and vice versa. If density decreases, pressure decreases. If density increases, pressure also decreases. Now, if we take average density of air as 1.29, this is average. Again, I am saying average density. And the density of mercury 13,600 kilogram per meter cube. We can find the height of air column, which will exert as much pressure as is exerted by 1 centimeter, that is 0.01 or 1 by 100 meter column of mercury. See, what we want to do here is, we want to calculate pressure. Whatever pressure is exerted by just 1 centimeter height of mercury. If same pressure is exerted by air, then what can be the height of the air which exerts same pressure as exerted by 1 centimeter height of mercury? That we want to calculate. Means whatever, again listen carefully, in barometer how much height is there? 76 centimeter at sea level. We don't want to calculate the pressure exerted by 76 centimeter. No, we want to calculate the pressure exerted by just 1 centimeter of mercury, right? So whatever is the mercury pressure exerted by 1 centimeter of mercury, same will be the pressure exerted by certain height of air. So P air, pressure exerted by certain height of air, is equal to pressure exerted by 1 centimeter of mercury. We equate. And then what is the formula for air pressure? H air rho air G, H rho G, H air rho air G, and H P mercury, H mercury rho mercury into G. G cancelled. H air is equal to H mercury rho mercury divided by rho air. Here we put the value. What is the height of mercury? 1 centimeter we have taken. 1 centimeter means 1 by 100 meter. Multiplied by density of mercury 13,600. Divided by average density of air. Average density of air. I am stressing on it. Average density of air 1.29. And after calculation, what we get? Answer is roughly 105 meter. Now, what 105 meter means? See, from sea level, what is the pressure here? 76. If we go up, the pressure goes on decreasing. Somewhere, the pressure may be 75 centimeter. Because here it is 76 centimeter of mercury. Here it is 75 centimeter of mercury. Now, you tell me, if the pressure is 75 centimeter of mercury here, and here it is 76, that means mercury pressure falls by 1 centimeter. Mercury pressure falls means we are going up. How much we go up? By 105 meter. So means if mercury pressure falls by 1 centimeter, what is the decrease in height of air column? 105 meter. Or what is the increase in altitude of that place? 105. Either you can say decrease in height of air, or you can say increase in altitude of that place. So it's one and the same thing, right? So if the pressure falls by 1 centimeter, how much height you have covered in the upward direction through air? Through air means You can go straight away also up by having some kind of lift or something, right? Then also pressure will decrease by 1 centimeter after 105 meter in the upward direction. So pressure falls by 1 centimeter means we move up by how much vertical height? 105 meter height. If you reach somewhere here, pressure is 74, then how much height you have moved up? Double. 2 into 105, that is 210 meter. If you further move up, maybe pressure is 73 here, then how much height you have moved up? 3 into 105. So that is 315 meter. If you keep on moving like this, after every 1 centimeter fall in mercury pressure, how much height you have moved up? 105 meter. If you reach the top of the atmosphere here, then what will be the pressure here? 0. So what is the decrease in pressure from 76 centimeter to 0? 76 centimeter decrease in pressure is there. Then how much height you have moved if pressure falls by 76 centimeter of mercury? How much height you have moved? 76 into 105. That is 7,980 meter. You have moved up to the top of atmosphere. Convert it into kilometers, 8 kilometers. Right? This way we can get 8 kilometer height of atmosphere. But you know, height of atmosphere is on the average 300 kilometer. Maximum it can be 1300 kilometer at some places. Minimum it is 180 kilometer also. It is not uniform. This is average only. But here answer is coming up to be 8 kilometer. Why? Why this answer is 8 kilometer? Okay, answer is coming 8 kilometer. What is the reason for that? See, when I am doing the calculation, I stress on one point, that is average density. And here it is mentioned also, moreover, while going upward, the density of air decreases, which also accounts for decrease in pressure. When density of air decreases, pressure decreases. But which value we have used in the calculation? Average value only. This average value, average density of air is taken. Right? This is average. But you know, as we go up, density goes on decreasing. And you know, if density decreases, density of air decreases, with that, pressure exerted by air also will decrease. Then how much you have to move up so that there is 1 centimeter fall in mercury pressure? Not 105 meter. You have to move much more than that. See, if density decreases, then H here, height of air column here, it comes to be 105 meter only. But if density further decreases, it becomes less than 1.29, then height of air column traveled upward, which can apply same pressure as applied by 1 centimeter, will not be 105 meter. It will be in excess of 105 meter, much more than 105 meter. Sometime, if the density of air goes on decreasing more and more, it can be in kilometers also. Right? That is why the 8 kilometer is not the height of our atmosphere. It is much more than that. Right? So the reason is given here. 8 kilometer of air column will exert as much pressure as 76 centimeter of mercury. However, it does not mean that atmosphere extends to only 8 kilometer. No. You know that approximately this is the height of our Mount Everest also. As it is pointed out earlier, the density of atmosphere also changes with the height. Density of atmosphere also changes. As we go up, density of air goes on decreasing. Thus, a fall in 1 centimeter in pressure does not mean that we have covered a vertical height of 105 meter. On higher altitude, very higher altitude, vertical height of air is far in excess of 105 meter. Means if the pressure falls by 1 centimeter, does not mean that vertical height of that place is 105 meter. It may be far in excess, but where? At higher altitude. For lower altitude, this is correct. 105 meter is okay. But for very high altitude, this becomes incorrect because of low density of air, right? And a graph showing this variation is shown here. You see that this is a graph, atmospheric pressure in centimeter of mercury and height above sea level in kilometer, right? You know, maximum atmospheric pressure is 76. So we touch this graph here at 76. You have to touch. If you are writing atmospheric pressure in centimeter and you are writing the values, you have to touch this graph at 76. If you are not writing these values, you are not writing 1938, 57 and all, only labeling is done, but values are not written, then don't touch this graph with this axis. Then graph can be like this, just pressure here and altitude here, and graph can be like, don't touch it anywhere, neither on the x-axis nor on the y-axis. But if you write the values like 76, then you have to touch it there. Very important point you have to keep in mind. And on the altitude side, you should not touch the graph with the x-axis, that is height. Why? Because height cannot be height. See, this is height is increasing, but pressure cannot be zero. This is 30 kilometer only. Our atmosphere is 300 kilometer average. So how you can write 0 here? You cannot write 0. So you should not touch the graph with the x-axis, right? So this is a graph which gives a relation between height above the sea level, means altitude of the place, and the atmospheric pressure in centimeter of mercury. Uses of barometer. Barometer as an altimeter. Altimeter is a device used to measure, altimeter is a device used to measure altitude of the place, height of that place from sea level, right? Now you see, we have already discussed, if the pressure, barometric pressure falls by 1 centimeter, how much height we have moved up? 105 meter. See, if the barometer shows reading 76 centimeter on Android barometer, reading is shown is 76 centimeter, that means altitude of the place is 0, that is sea level. If the barometer shows pressure 75 centimeter at certain place, pressure shown is 75 centimeter, then what is the altitude of that place? Because pressure falls by 1 centimeter from 76 to 75. So altitude of the place is 105 meter. If pressure further falls to 74 when we go further up, then what is the height of that place from sea level? 210, double of 105. At 73, 315, 3 times of 105. 72, 420 and so on. So if in case of Android barometer on the scale, if in place of pressure we put altitude at 76 0, 75 105, at 74 210, 73 315 and so on, then that Android barometer behaves like altimeter, means it becomes a altimeter for us. So what use of barometer? That it can be used as altimeter also. Now barometer for forecasting weather. Atmospheric pressure decreases mainly due to 2 reasons. One, there is increase in temperature. When temperature increases, density of air decreases. With that, atmospheric pressure falls. So because of increase in temperature, atmospheric pressure falls. And because of increase in moisture, if moisture increases in the air, with that also, when moisture is more and more, then also the density of air decreases. With that, atmospheric pressure also decreases, that means falls, right? In the first case, as air expands due to heat, in case of temperature, density decreases, therefore pressure decreases. In the second case, increase in moisture also decreases the density of air, and therefore it results in decrease in pressure. Pressure falls in this case. Thus following situations can arise. These situations can arise. What are these situations? I'm see, if there is a fall in pressure, I'm showing it here, you just check it out. See, pressure falls, and fall is due to few reasons: because of temperature, because of moisture. If pressure falls because of temperature, not because of moisture, moisture is not increasing but temperature is increasing, increase in temperature is there, then what is the prediction? Dust storm is possible, because moisture is not there in the air. Wind will blow and very strongly it will blow, then moisture is not there, then what do you expect? Dust storm only will be there, right? So if the pressure falls not just because of temperature, not because of moisture, then what is the prediction? Dust storm. Now if pressure falls because of moisture, and the fall is of two types now. One is gradual fall, slowly it is falling over few hours time, or sometimes few days time, it depends, or suddenly it is falling. If it is falling gradually over a period of time, then what is the possibility? Maybe we are moving towards rainy season. If pressure falls every day, little bit it fall, keep on falling gradually for 10, 20 days, 15 days, okay, then that means we are moving towards rainy season. But if we are already there in rainy season and the pressure falls slowly from morning to evening, it falls little bit it is falling, that means there is going to be rainy weather. Rain possibility is there, rainy weather is coming, maybe in a day's time, maybe in 2 days time, but it is approaching. And if there is a sudden fall in pressure due to moisture, not because of temperature, due to moisture, sudden fall in pressure is there, then what is the expectation? There may be rain. If the fall is not very sudden but not very sharp, the rain. If the fall is little more sharper, then maybe rainstorm. If it is highly sharp, then it can be cyclonic weather also. Depends how that fall is too sharp, then cyclonic weather. If less sharp, rainstorm. Very less sharp fall is there, less sharp fall is there, then it can be rain also. Depends. Means if sudden fall is mentioned, you can write anything, all answers are correct for you. If there is a normal pressure, means the pressure is not falling, not increasing, it is stable only, that means fair weather. Fair weather means no rain, no wind is blowing, it's a normal day of the season. If it is summer season, it's a normal hot day, right? If it is winter, it's a normal winter day, no clouds, no rain, no wind, normal one, right? If pressure rises, again due to two ways are there of rise, one is gradual, one is sudden. If gradually pressure rises, gradually, slowly it is rising, that means we are moving towards dry season. Okay, in India, dry season is basically winter season only. So we are moving towards dry season. And if the pressure rises suddenly, okay, that means, and we are moving towards dry season, season is dry, but very quickly it changes to anticyclonic weather also, right? So these are prediction. Again, I am showing this page, you can take a screenshot, easy for you to understand what are the prediction. And then fair weather, and then pressure rises, then predictions are given here according to what type of change is there. Now beta, next manometer we have already done earlier. Come to effects of atmospheric pressure. Effects of atmospheric pressure. First is, why is the tremendous atmospheric pressure surrounded by us is not felt by us? It is because our blood have dissolved oxygen in it. You know, our blood have dissolved oxygen. When we respire, the oxygen dissolve in blood in our lungs. And that oxygen have a pressure slightly more than atmospheric pressure. So means pressure of oxygen dissolved in our blood have a pressure slightly more than atmospheric pressure, and the pressure in our body now, because of oxygen dissolved in blood or whatever fluids we have in our body, so that pressure of oxygen counterbalances the atmospheric pressure. Right? If you take a page and press it equally from both sides, the page will not feel any pressure at all, because pressure is balanced on both sides. If one side more, one side less, then bending is there. Collapsing may be possible. But because both sides, from inner side of our body and from outer side, right, both side pressure is same, and therefore we cannot feel it. And this is the reason. Next, otherwise, what is that atmospheric pressure? I have told you roughly 10,000 kg. Roughly equivalent to 10,000 kg. If 10,000 kg is put on an area of roughly 1 meter square, right, then pressure will be roughly 1 atmospheric pressure. Right? So, it's very large actually. Still, we are not feeling it. It's because of this counterbalancing of pressures. Why does the nose start bleeding if one travels in a non-pressurized aeroplane or one goes to some higher altitude? Okay, mountain areas, very high altitude you are reaching there. Then, why it happens? See, in our body, when we are at normal height, in our body, oxygen is dissolved. That oxygen have a pressure slightly more than atmospheric pressure, so inside pressure is there. But when we go to some higher altitude, outside, because of altitude, when we go to higher altitude, pressure decreases because height of air column decreases. We have already discussed. So pressure outside decreases, inside pressure is more, outside it is less. And fluid, that is blood in our body, move from high pressure to low pressure. Means it will come out, because inside our body high pressure, outside pressure is low. So it will try to come out of the body. And from where it can come out? Wherever loose blood vessels are there. And weak blood vessels are there in the nose, and therefore blood capillaries in the nose, they break and the blood start coming out. Right? It is for the same reason. Because of this problem only, in aircraft cabins are pressurized. Means in aircraft, aeroplanes, they are pressurized. Means inside pressure, atmospheric pressure is maintained by machines. Right? So these two questions are there and answers also. But for this second question, answer will remain the same. Only for few wording you have to write at the end. It is for the same reason that astronauts have to wear special space suits. Astronauts, they are in the space. In the space, pressure is not there or very less. In the near space, pressure is less, very less. But in the space, it is not there at all. As you go up, so outside pressure is not there. Inside the body of the astronauts, very high pressure, atmospheric pressure. So then what will happen? The blood start coming out, and not just from the nose, from everywhere. That means the body of the astronaut will burst. It will burst like anything. Because internal pressure is very, very high, atmospheric pressure, and outside pressure is not there. So that is why they are wearing specially designed space suits. Okay, specially designed space suits they are wearing. Now, it is for the same reason that deep sea fishes, see, those fishes which live deep in the water, see, this is water level, and if roughly if we go 10 meter into the water, 10 meter into the water, 10.34 exactly, then what pressure is applied by 10.34 meter, roughly 10 meter of water. It is equivalent to 1 atmospheric pressure, means pressure of atmosphere. If you go down by roughly 21 meter, then what is the pressure? Roughly 2 atmospheric pressure. Right? So as we go down, pressure goes on increasing. At a height of around 1 kilometer below water, pressure is very high, 70, 80 times more than atmospheric pressure. And those fishes which live there, they are never used to come on the top. Okay, inside their body oxygen is dissolved. That oxygen have a pressure more than pressure here. 80 times of atmospheric pressure or 70 times, whatever, right? So inside pressure is more, and outside water pressure is also more, and inside pressure counterbalances outside pressure in the body of the fish, and it can easily live there, no collapsing. But if this fish is brought to the surface, then in their body 80 at times or even more atmospheric pressure is there, but outside 1 atmospheric pressure, inside 80 times more pressure, outside very less pressure, 1 atmospheric pressure only. Then what will happen? The body of the fish will burst. In this case also it will burst, right? So this is also question and reason given here. Now, why do fountain pen leaks on higher altitude? Fountain pens pen leak on higher altitude. Why? See, fountain pens are just, nose starts bleeding. Why? Because inside our body pressure is high, outside it is less, so it starts bleeding. If ink is filled in the fountain pens at normal altitude, so that ink have a dissolved air in it and therefore have a pressure equal to atmospheric pressure. If that pen is brought to higher altitude, outside pressure decreases because of altitude, but inside the pen, ink of the pen inside, pressure is high, and fluid moves from high pressure to low pressure, so fluid will come out of the pen. So that means fountain pen leaks at high altitude. Why we cannot suck lemonade on the surface of moon? First of all, I'll explain how we suck lemonade on earth. How we drink cold drink with the help of straw. See, this is a bottle of cold drink, and here we have cold drink, and this is a straw. Straw is going out, and here your mouth. You are taking it inside your mouth. Now, what is the pressure acting on the level of liquid inside the cold drink? Atmospheric pressure, high pressure. And you suck the air from the straw. When you do it like this, suck the air inside, the air in the straw goes into your mouth. When the air goes into your mouth on sucking, then inside the straw pressure falls, low pressure is there, right? Because air applies pressure, air you have sucked into your mouth, so inside the straw pressure decreases, and therefore high pressure in the cold drink bottle that pushes the cold drink up into the straw and ultimately into your mouth. And this is how we are able to drink on the surface of earth. But problem is, on the surface of moon there is no atmosphere. Almost no atmosphere is there, or very light atmosphere is there. We can say no atmosphere is there. So because there is no atmosphere on the surface of moon, hence we cannot suck cold drink with the help of straw on the surface of moon. Right? So this is the reason discussed here. Okay, beta. Now numericals are left, so that I will do in the next video. Thank you.